Hey there, my name is Miss Townsend, and I love math. Welcome to Math with Townsend. We're looking at the grade 10 academic summative, the analytic geometry and linear systems portion. This is part 2 of question number 3. Hopefully you watched part 1, and if you watched part 1, you notice I made a very tiny mistake at the very end. I just recopied something wrong. So this is what we discovered by doing part 1. And the mistake was right here. I wrote this as y equals -1, and therefore these were wrong on that video, but I'll put that in the comments. You'll figure it out. Anyway, this is what we discovered in part 1 of question 3. So this was the question that said, determine the equations of the medians from each vertex. So we reviewed what medians were, and we algebraically found each of the 3 median lines, and then we made sure to put them in both slope-intercept and standard form, just in case that's what your teacher wants. So now we're on to the next part. So the next part says, determine the coordinates of the centroid, which is the point of intersection of the medians. So we know that, just in case. The centroid is the point of intersection of the medians. Boy, it said it right here. I guess I didn't really need this fancy little thing, but that's okay. So again, every triangle has 3 median lines. And those median lines are supposed to all intersect at the same point. And that point, we give it the name centroid. So let's look a little closer at this triangle. So for example, we found the median line from Q to J, and it looks like this. And then we found the median line from R to K, and it looks like this. Now, you can see where those two lines are intersecting. So when we look at the third median line, if we've done everything right, including my little graph here, then they'll intersect. The third one will also have the same point of intersection. So here's that third median line from P to L, and you'll see that they intersect in the same point. And that point is called the centroid. And that's not unique to this triangle. In every triangle, the 3 median lines will intersect, and that point is called the centroid. So we have to find the coordinates of this point. And again, we're not going to find it by looking really closely at our graph and making a guess, right? That's just not how you do it anymore. And there's no way I would try to guess what that was. We have to do it algebraically. So again, here I've summarized the information we found in part 1. I've got 3 median lines. How do I find the intersection of 3 lines? Well, you do it in stages. We're going to find the intersection of 2 lines. So I'm going to do the intersection of this line and this line. And then we verify that it works in the third line. Now I realize that I'm kind of giving myself the hardest task because I'm choosing P and Q, and life would be easier if I picked R, but I'm here to demonstrate, and help you learn, so I'm not always going to take the easiest route. I'm going to take the slightly more challenging route. I'm going to take equation number 1, which is the median from P, and equation number 2, the median from Q, and I'm going to solve the intersection. So we could take the lines in this form and solve by substitution, or we could take the lines in this form and solve by elimination. Both methods are perfectly fine. I'm not sure which one was better to do. Um, so I'm going to do the harder method because why not? I'm going to take these 2 equations and I'm going to solve by substitution. So we know that according to equation 1, y equals -3x minus 4. And according to equation 2, y equals -6 over 7x minus 3 over 7. So let's start with equation 1. Y equals -3x minus 4. And we're going to sub y equals -6 over 7 x minus 3 over 7 into equation 1. So in other words, instead of writing y equals here, I have a value for y here that I can write instead. So that's my substitution. And let's do that math. So instead of y equals negative 3x minus 4, here is what I know y is equal to. And I wrote something a little funny, so let me fix. That minus sign should be a subtraction sign. There we go. So now that I've done that substitution, I'm left with one equation with one unknown called x. And now I'm going to solve for x. So there's lots of different methods you could use. I'm going to multiply everything by 7. So I'm going to multiply the left side by 7, which is nice because it'll get rid of those fractions. And therefore I have to multiply the right side by 7. So again, on the left, when I multiply by 7, all that happens is the 7 in the denominator goes away because multiply by 7 and divide by 7 cancel each other out. Here, multiplying by 7, well, nothing gets canceled, so I actually have to do this math. 7 times negative 3 and 7 times negative 4. Good. So now I'm going to rearrange this equation. I'm going to add 21x to both sides. So negative 6x plus 21x. So negative 28 stays where it is. Negative 3 becomes positive 3. So negative 6x plus 21x is 15x. Negative 28 plus 3 is negative 25. So x equals negative 25 over positive 15. And that reduces to negative 5 over 3. That's the value of x. And again, I've got a graph on another page that just disappeared. Hold on, I'll reclaim it. Click, click, click. What do you think of my nice fade in and fade out? So I just discovered that x is approximately negative 5 over 3. Negative 5 over 3 is like negative 1.666. And does this point look like an x value of negative 1.666? Yeah, I think so. So I'm pretty happy with my math so far. So that's the x value. So now I am going to sub x equals negative 5 over 3 into either equation 1 or 2. Let's sub it into equation 1, which said y equals negative 3x minus 4. Here's my new value of x. So y equals negative 3, so 15 over 3 minus 4. Y equals 5 minus 4. Y equals 1. So the intersection of 1 and 2 is negative 5 over 3 comma 1. And I'm just going to, really make sure I'm right. If I sub negative 5 over 3 in here, let's make sure that it works. So I'm going to do check sub negative 5 over 3 into 2. So this is what equation 2 says. Was it 3 over 7? Yeah. So to be really sure, I'm going to double check in equation 2. So multiplying fractions, I get positive 30 over 21. That reduces to 10 over 7. Oh, looking good. So y equals 7 over 7. Y equals 1. Yay! Now, I'm absolutely certain that the intersection of 1 and 2 is this point here. But I had a third equation right here, and I haven't used it yet. So we also have to verify. Now, hopefully you did that very quickly mentally. We also need to verify. So let me get a new page here. We need to verify that negative 5 over 3 comma 1 is on line 3. Now the equation of line 3 says this. Clearly, y equals 1. So you could also think of this as the line y equals 0x plus 1. So y equals, so, oops. So if I sub that point in, I know this is redundant, but let's show it anyway. If I sub in 1 and negative 5 over 3, I get 1 equals 1, a true statement. Therefore, this line, this point is on this line. So now I know that the centroid, so therefore, the centroid is at negative 5 over 3, comma 1. Excellent. We're still not done this question. We have to do part D. It says show that the distance from the centroid to each vertex is twice as long as the distance from the centroid to the midpoint of the opposite side. So, in other words, show that the distance from C to Q is 2 times the distance from C to J. And the distance from P to C, so CP, is 2 times the distance from C to L. And again, that the distance from C to R is twice the distance from C to K. So I don't have a lot of time left before I run out of YouTube space.